Hey, how's it going? You're both muted. Oh, there we go. Hi, guys.
Morning.
Oh, I have to crank up my volume. Or I might have to change my settings. One second. No, it should be good. Are you guys talking or am I missing? I'm not hearing you. Okay. What? Oh, I hear Rob. I don't hear Payam.
Yeah, I don't hear you.
So, Rob, I think this is the paper you've been looking for.
This one? Wow.
Yeah.
Can you hear me now?
Yeah.
Okay, good.
Kind of weird, but yeah.
Well, why don't you kind of fill Payam in on what we've been trying to kind of move towards? And first of all, did you have a chance to look at the paper, Rob?
The one posted?
Yeah.
Yeah,
So
I mean, I
go ahead.
I don't understand it, and I don't understand why it's important.
Excellent.
Oh, that's interesting because I really enjoyed it. I thought it answered a lot of the questions I had. But okay, I am interested to know why you don't like it.
I didn't say that. I said I didn't understand it.
Okay.
Okay, so let's take a one-dimensional case. So is the paper saying that as I expand the sample size, I'm going to get something outside of my range? My convex set of, upper and lower, minimum and maximum values.
Do they say that?
Oh, I'm asking, is that a correct characterization?
I didn't interpret it that way because I don't think that's expected or so you're basically asking about extrapolation that generalizes to some truths, right?
Well, okay, so he starts off by talking about how we have this notion of internal interpolation and extrapolation. And as I'm reading the abstract, I'm thinking, okay, that kind of describes my view of it. All right, this makes sense. Now tell me why I'm wrong. So in terms of defining sort of what's inside, going back to his definition one, in terms of understanding what's inside his definition one, if we got a single variable, then that's going to be sort of the minimum and the maximum of it. Is that right?
Sorry, I'm just looking for definition one.
Let me see if I can pull it up here.
We're talking about to explain or predict. No?
I thought so. Maybe we read separate things.
Maybe I got the wrong paper here. Okay.
Oh.
Hold on.
Which one did you read?
Learning in high dimensions always amounts to extrapolation.
Oh, okay.
Oh,
okay,
that's
okay,
ancient.
okay.
Sorry.
That's
yeah,
a different one. Yeah. That one I totally agree with you that it doesn't make sense and it's a crappy paper.
I don't know if it's crappy or not. I think it's interesting because I mean, I find stuff interesting that sort of challenges my intuition or understanding.
No, it's definitely interesting, but what I found, what I didn't like about that paper is they come up with that definition of convex hull to define interpolation, and I just don't agree with their definition. Their definition is not relevant to the problem they're trying to sort of shed light on. I mean, it's one definition, and I think if you read the last line in that paper, they say, oh, you could come up with new definitions that will fix this problem, and we are hoping to encourage you to do so. So once you come up with a better definition, I think everything they talk about becomes not super relevant to real practice.
All right, so the problem really was user error. I looked at the wrong paper.
No, I'd love to return to that paper. I just don't have it loaded in my brain right now. Okay, so I'll bring up this one and we can kind of, Rose, how are you?
I'm sorry, I looked at the alt deep chat and it was there. So I just,
I think you had to hit
Okay, I'm
refresh and it'll come up. Did you have a chance to look at the paper, Rose? I can't hear you, you're muted, sorry.
Sorry, yes, I skimmed the paper.
Okay, I didn't read every line, but I kind of had a good chew on the beginning and the end. So, Pam, can you kind of share your intuition as to what the paper is about? Because Rob's not.
Yeah, yeah. So the paper, I guess,
can
the
you post a link
titles.
for it? Somebody?
Yes, David, you can do that. Yeah, so it's basically the title is pretty well explaining the paper. Is so when you're doing, I guess they're trying to make a distinction between if you want to develop a model or create a model for explanatory purposes versus prediction purposes. They're arguing that's two different axes, two different dimensions that you can decide to go, and they're not necessarily consistent. So if you want, so this part is, I guess, pretty intuitive, that if all you care about is predictive power, you could do well, you can do better in prediction than if you also care about explanation, because predictive power models can basically use lots of different correlations and things that have, and actually the function you learn while you're doing predictive modeling is learned from the data. So it doesn't necessarily have any theory behind it, but it could use these correlations to do better prediction. Like in finance, basically they use finance as an example because basically they're saying most of the explanatory powers have really poor predictive power. And so the academia is focused on explanatory modeling, and then the industry is focused on predictive modeling, and they don't really talk to each other because they find each other irrelevant. So, so that's like one extreme example they give in the paper, but there's lots of other ones. Go ahead.
No, yeah, I mean, that strikes me as a highly relevant distinction.
Yeah. I guess that some of the questions, I think we had discussed this in this group a bunch of times, but some of the issues I had was, okay, if you have a really good explanatory model that actually captures causal relationships, you should have predictive power. And if you don't, then your model is wrong. And they're not, so I was confused between this distinction, but they're saying, sure, your explanatory model should have some predictive, but it's not going to be the optimum. If all you care about is prediction, you don't care about the cause and effect relationship, you care about the prediction. So they talk about that. Yeah, so the main thing that's interesting, and I think, so basically neural networks, they don't talk about neural networks as much in the paper, but I think they're focused on prediction, and there is no cause and effect, as we know. But the main distinction between explanatory models and the other types of models are whether you learn the function representing the data through the learning, through the training or the fitting, or do you bring it from somewhere else, and that's primary, and then you just use the data to fit it. And I think that's the main difference. And so in case of neural networks, obviously it's like a high dimensional polynomial, you just fit to the data. It doesn't assume anything about the structure or any theory behind your data. So it can do well on prediction. But it's interesting because lots of people are working on explainability for neural networks. So I think it might be doomed to some kind of failure because there is no explanatory power within the data itself. You need to bring it in, which is what UDL Pearl and all those people are sort of talking about. Yeah, so I guess, David, you read the conclusions. So at the end, he tries to bring it together and say, of course, we need both. We need to sort of merge them together in a synergistic way. And but I thought the distinction is interesting, and he goes through the history of how in different fields people basically, I mean, the statistics for a long time, people thought prediction is unscientific because they cared about just the inference in the small data points. And also, I guess another sign that you care about predictive modeling is if you seek out more and more data points. So that's something that helps out with predictive power, but not with explanatory power. So they say for explanatory, usually you just want to have a small number just to test your explanation, but you don't care if you have 1 billion data points or if you have 5, your theory could be just as good. Whereas prediction keeps on improving as you add more data points. Anyway, that's the summary, but there's lots of interesting little bits and pieces we can talk about.
Yeah,
So
I mean,
we can't, sorry, go ahead. Go ahead.
no, go ahead.
No, please. That's fine.
I was going to say, I mean, academics tend to have a model-based view of the world. So that's how you succeed in this business, actually. You think about models, you think about predictions of those models. You think about testing the models and then sometimes interpreting the parameters of those models that you estimate. So, yeah, I mean, in that sense, the notion of generating a prediction is sort of, okay, why would I do that?
Yeah, there is a famous quote in the paper, something about, if you want to make money, you predict. If you want to find truth, you explain. Like something like some statistician, which is, I guess, what you're saying.
Is that in this paper?
Yeah, it's somewhere.
Yeah, as I say,
Rob,
Rob, if you do take the time to read the paper, it's actually dead on what we've been talking about for a long time.
Oh yeah, well, definitely.
Yeah, it's a really well-written paper. It's really good.
Yeah, no, it's very good. I just want to drag you into category theory for 2 minutes here. I just want to share my little insight here. So I'm just going to return to the adjunction, right? So we have some point, some state, and then we have something that we don't know, which takes us to this other state over here, which we can observe, right? So we can observe this state over here. We've got a little I here. We're looking at the outcome. There's some unknown function here that we're trying to approximate, okay? And we have this pathway where we can take the state of the system, we can load it into a model here, and then we can run that model forward in time, okay, to some new state, and then we can observe that state again, all right? And we can have any number of these, right? So these things up here stack, right? So there's lots of different ways where we can essentially take the current state of a system here. We can lift it into a model. We can make a prediction, and then we can derive observations from that model back down into something we can observe. And some of these models are explanatory and some of them are predictive, is the way I would describe it, right? And what we're looking for is a model that is both explanatory and predictive. Okay, if you have an explanatory model that has no predictive power, then your model is wrong. If you have a predictive model that has no explanation, you can't make any assertions about out-of-sample distributions, is my understanding. So that's how I would characterize it in terms of an adjunction. Does that make sense?
Yeah.
Yeah.
Kind of,
So,
except for the last part. So, it seemed you can make some characterizations about the out-of-sample distributions just by looking at your predictions and kind of looking at whether they work or they don't.
sometimes that will be true. I'm not trying to be mean, I'm just saying that we can't, I don't think we can be as confident of a predictive model that has no explanation to give us good out of distribution samples.
Yeah, I mean, that's what the academics would say too.
Okay.
It takes a model to beat a model.
They give a really good example of like a very simple example of like prediction versus explanation. Like let's say the price of airline tickets go up as a function of like the price of oil. So they say that's a very well understood explanatory model, right? Like if you know the price of the oil, then you can estimate the price of, or the price of the airplane tickets. But that's a useless predictive model because you don't know you need to first predict the price of oil to then predict the price of the airline ticket. And if you have to do it you will need other things to predict. So that explanatory model does not have any predictive power, but it explains very well what's happening. So every time you see that the airline tickets went up, you can be sure that the oil prices also went up. So you understand that mechanistic behavior, but you can't use it to predict what is the airline tickets going to be like 2 weeks from now, because you don't know the oil price. So he uses it as a way that how can an explanatory model be accurate and useless for prediction.
So which is the greater evil, predicting without explanation or explaining without prediction?
No, I think that's the whole point of the paper. Like it's not, it's a complementary thing. So at the end, he talks about this spectrum, or like at the 2 dimensions, right? One is explanatory power, one is predictive, and each model is somewhere in this 2-dimensional grid. So if you go to like physical sciences, they all have, so that's what sort of confused me, because I'm biased by sort of my training in physics, because all models have super high explanatory power and also super high predictive power, because the data is simple, it's not messy. And I thought that should be the goal for any explanatory model, to be able to be also super predictive. But I think when you go to messier domains like psychology, sociology, economics, and all those things, then you're sort of somewhere in this domain. And maybe if you are like trading in financial markets, all you care about is predictive power. I don't think it's evil. You want to make money, you don't care why the price of something goes up. As long as you know it will go up in a week, you can make money off of it. You couldn't care less about the explanatory power of it. Or if you're writing papers, maybe nobody cares that you can predict something. They want to know why you think something is correlated or causally related to something else. So basically, he's advocating, if you want to develop a model, first be clear what you want. So what is it that you're trying to achieve? And then he outlines all these steps of pre-processing, post-processing, the way you look at the data, the way you limit your models to decide which one is going to be best.
The description.
He doesn't talk about interventions all that much.
Yes.
And I think it's interesting when we talk about explanation and prediction, because intervention becomes a very important part of it. We explain because we want to intervene. And I think we've started to use predictive models, and we're implicitly intervening and then not understanding that that's what we're doing. And so we're changing things. And Payam, I think it's interesting when we talk about the physical sciences, because he gives the example in there of, I think it was Galileo, and using predictions and still using predictions, even though when we know the explanatory model is wrong. And I think what's interesting about those cases is that the things that exist in the world as things, as opposed to constructs that we've created. And he touches on this a little bit in the paper, that there are these sort of soft constructs that we create that are very different than physical reality, right? They've come about by human intervention, human models of thought, that's very different from a physical reality that's out there. And I think it's interesting in terms of some of the other more philosophical papers that we've read recently about what is a thing? Like, how do you know if it's a real thing, as opposed to some creation that we've come up with, and whether or not that will respond to an intervention in the way we expect it to.
Mm-hmm. Yeah, I mean, I think that's also a problem maybe more recently for even physical models, right? Because they hypothesize the existence of these things that are unobservable, like it's not just a matter of technology. They're just so small, they'll never be observed. It's just something, maybe around Boltzmann time, it made sense to hypothesize like atoms moving around and molecules moving around. You couldn't see it, but now we can see them and we confirm. And he turned out to be right. But when he came up with it, there was no reason to believe these things exist, right? He just made it up. And it just happened to be a good thing he made up. But you're right. I mean, when you go to more messy fields, like you have no idea if whatever you made up is useful or accurate or represents anything. Yeah.
Yeah, the other piece of it was that one of the things he called out that I hadn't seen called out in some of the other papers that we've looked at is the missing data, and how missing data is so useful in a predictive model, but in an explanatory model it gets in the way and we disregard it or we impute or something. I think that's also interesting in terms of some of the philosophical issues that we've been talking about, the sort of the unknowns, right? And when you just don't know something, knowing how to take that into consideration in some way.
Yeah, he gives the example of the Netflix prediction, which was interesting. So it turned out that what was super important in predicting what movies to sort of recommend to what users is which movies they chose to rate. It didn't matter how they rate them. It didn't matter what they were, who they were. It's just which ones they chose to rate. That was the most predictive thing. And the way they got it to predict better, they just like got together with a bunch of people who had developed different models and they averaged all the results and they got the best result, which has zero explanatory power, but really good predictive power.
I think that's really interesting, and it sort of gives us I think the missing data gives us a sort of an idea of what somebody's working model might be, right? It's eliciting a strong reaction of the person for whatever reason, and we might never be able to explain what the reaction is, but the fact that there is a strong reaction, it might point us to some sort of model that's driving how they make decisions.
Right. The movie contains something super salient, and that is what was driving the rating. And so it was so salient that people felt compelled to write a review.
I guess one of the challenges I see is that most of the empirical models I encounter are really kind of imprecise in that the R-square is typically pretty low. Okay, so that tells you that there's a lot of other stuff going on that your model's not explaining. And oftentimes, a lot of that other stuff winds up being kind of correlated with something you might be interested in. I mean, if you look at a randomized trial, that's essentially a linear regression on a single dummy variable. Okay, now, if the R-square from that winds up being 0.05, you're generally going to have a highly statistically significant coefficient. And you're going to conclude there's a difference between these two groups. And, I mean, that's not a bad inference. But then on the other hand, you got probably 95% of the other variants that's sort of out there unexplained. And people are saying, yeah, I don't care about that.
So there's a concept in neuroscience around the idea that we can only hold a fixed number of things in our head at any given time. And perhaps the distinction is that when we construct explanatory models, we can only have a vocabulary of less than 10 parameters that we can use in the explanation. This was covered by Pearl and Wolfram in their discussion. And so perhaps the real benefit of machine learning is that it can impute these parameters from the data, and it can actually hold more parameters in mind, as it were, than we can. And so the predictive power of these kind of more than 10 parameter models is actually superior, simply because they're considering more factors in heavily confounded environments. So perhaps the problem is in our head and not in the models at all. And we're just mad that we can't understand these 20, 39 million parameter models because we don't have the cognitive equipment to do so.
I mean, this is related to what Rose also talks about too. So he talks about it in the paper that if you're trying to develop like a causal model, you sit down, you draw, like you can imagine sort of features that might be important, you draw your diagram, but then you go see, okay, how can I observe effects of these features? And you design some experiment to observe certain things. You can't observe necessarily what exactly you have in your model. You can observe some result of it in the real world, and then you go collect your data. But whereas in predictive power, you don't need to come up with any of these features. You could have thousands or millions of features, as you said, David, and the model fits a function that fits all of those, and the aim is to maximize predictive power, but there's no understanding.
It could generate an explanation that we are completely incapable of understanding.
But there is no explanation, though. Sorry.
Can I
in the sense that we could,
about the features? Like, I don't think that's true. I think some amount of theory has gone into the features in the first place. It's not like we're out there collecting every single signal that's out there all the time, right? So maybe it's different, and like we've talked about vision before. Okay, well, maybe that's a case where we're not doing a lot of selection before we even begin. But when we're using like medical records or even financial records or something, we're already applying theory, right? There's a whole load of theory that's gone into that data collection before we ever.
That's fair. That's fair. And I think go ahead.
I guess so. It's just the point I wanted to make is that's where it becomes dangerous, right? Because I think it's nice if we say, well, we let machine learning go off and find whatever signals it gets, and if it does prediction, like maybe sometimes it's telling us stuff that we can't understand. But when we apply machine learning to data that we have already curated to a certain degree, we're almost like we're driving a feedback loop then, because we're sort of telling the machine in a way what to come up with before it ever begins. And that's the piece of it that like I have a big problem with. It's, that's when you end up with the very biased models then that like say things like, women are poor engineers, or whatever it is. Like I predict that you shouldn't hire this person for whatever reason. And that's, I think, why we need the explanatory models, even for those big models, because we need to understand what it is they're looking at in order to make the predictions. Like we can't just put our hands up and say, okay, well, find whatever you find, because I think it's a feedback loop before it ever begins.
Yeah, I think that's fair, but it's tricky. I think in practice, like the example you gave, like whatever, women are better engineers or not, like if you go from the data, you're obviously including all the bias of historical bias, lots of other things, you get the wrong answer. But then there is no way to come up with the explanatory model. You have to draw an arrow just based on your own intuition that maybe women are better engineers, and you can assume that, and you go collect data. So it gets really tricky. Like I think maybe it's really hard to find the actual ground truth in any of these situations. So I don't know at which point we just say we can't trust these models, and okay, what do we do now?
I mean, I think that's why I've really enjoyed it when we've been reading the more philosophical papers, because I don't think any of these are new problems. Like a lot of the things we've been talking about is this whole a priori knowledge, right? And the fact that we are prone to set ourselves up to see the world a particular way because of our experiences to date and because what we've been taught. And this idea that we completely disregard data that doesn't align with what we already believe. And when you then add the power of technology to that, it really increases that feedback loop even faster. And that's why we've ended up with these problems that are, it's hard to roll them back because of the scale and speed with which they move forward.
Is it because they're rolling forward? Is it because they have, so from the, sorry, I'm pulling in all this weird stuff, but from the, from Dawkins' evolutionary game theory stuff, there's something called an evolutionarily stable strategy. So models that persist for a long time will accrue, will essentially select into models that continue to persist for even longer times, right? So we end up essentially finding these, stumbling into a valley, and then as we travel further down the valley, it gets deeper and deeper and deeper and deeper, and we're way down in this valley, and to climb out of the valley, it's literally impossible.
Yeah, I like that idea, but I think what we see in practice is that it just reinforces power structures that are already there.
This is what I'm saying, is that the stability is the positive feedback, right? So no, don't change the model, because then I won't have my job, or I won't have a competitive advantage. So I'm not going to publish your paper, because then people wouldn't need to publish papers anymore, right? And so there's all these kind of parasitic effects that are essentially preventing the model from moving, because there's a whole ecosystem around that model that's depending on it, and they are protecting it from change. And your ability to essentially punch through that kind of protective layer to actually get at the model underneath is often a fool's errand. Like, you just can't.
But I feel like there is some hope in, like, maybe human greed, or so if you have a model that like mischaracterizes like people's abilities, and it keeps feeding back on itself to do that more and more and more, I think there's an opportunity for a new model that come and recognizes people who were sort of ruled out as a part of that model, to then have actual like financial gains for whoever comes up with a new model, right? Like, if you're like a new Amazon trying to hire, and you come up with a model that maybe picks differently from the traditional model, you actually you have an opportunity, right, to make more money than Amazon and be more successful. So I think that's something that people will probably try by different means.
To a certain degree, but I believe that certain institutions become so stable that even new theories can't move them. Catholic Church, right? That they end up being so well protected, and they build up all these defense layers, all these kind of churches and clergy and all this kind of infrastructure that preserves the model. Oh no, we can't change anything. This book hasn't changed in 2,000 years and it never will. Right, you've got you can't change it. You can ignore it.
But it is changing, right? I mean, compare it to like even like 50 years ago, like look at what Pope is saying is like all for gay marriage is like this, that was unthinkable, I would say 50 years ago, right? I think they've been forced to change.
So there is drift within, in order to remain stable, that sometimes there is no choice but to move a little. But
you know what's interesting about that is that it's the time, right? There is something that happens with organic time, maybe through people dying or something, and so ideas change. But what worries me about the technology aspect of this is that part of things is really, it's speeding up so much that we don't have the normal checks and balances in place that the time would allow to happen, right? And so huge changes are made to things that have been around for a very long time before we have a chance to sort of catch up with, oh goodness, this wasn't such a good idea after all. Like it's spread beyond where it really ever should have. And it's okay, well, there's no putting this back in a bottle now, it's gone.
Right, right. We can only consider counterfactuals. We can't consider interventions that can take us back to the past.
Mm-hmm. And I think there's an element of what's happening right now. Like there's that whole like Facebook thing of, move fast, break things, right? Because it does become about profit as opposed to what's really the right thing to do, right? And
well, so the right thing to do is to make more profit.
I mean, I think that's the problem with utilitarianism, right? Like, is that the right thing to do? Like if you're using some sort of utility function to make your decisions and you never look outside of that, then you're always going to get the same answer, right? And it doesn't matter how much you're impacting other parts of the system and breaking things.
So there is one problem with this solution, which is if everybody's dead, it doesn't work anymore.
But
that's too late, right? Like,
well, I mean, finance is an answer for that.
Oh, don't die, no?
Sure, it's just, discounted present values. Everybody's dead, discounted present value, yeah, because if everybody's gone, that's, no point. But no, I mean, you know, this isn't kind of a subtle point, but you can make you can make very good arguments that maximizing profit is generally about the best thing you can do. You know, subject to certain constraints, you know, obeying existing laws and stuff like that. And the reasons why are you have the ability to pay people more, so you elevate their salaries. You're using resources more efficiently than some alternative use.
It's I'm not arguing with you, Rob. I'm just suggesting that it's inductive, right? You're only looking one time step ahead. You're not looking off into the distant future. If there was an intervention that we could take that would not be profitable for 300 years, but would allow us to live for another 20,000 years as a species, and there's profit to be made right now for the next 100 years, we're going to take the profit every time, and we will forego future generations' ability to exist for the short-term profit.
Well, you know, maybe not 300 years. Okay, you know, I'll concede that one. But if we're looking at, I mean, there are lots of companies out there that, I mean, they're publicly traded, positive stock prices, and they're upfront. They're not going to make any money for 2 or 3 or 5 years, and then they hope to do real well.
So to briefly venture off into Carr's finite and infinite games, you're playing a finite game, Rob. You're playing by the rules. You're not breaking the rules, and you can influence the rules, but you're not changing the boundaries unless you can. And the only reason that you would change the boundaries would be for your own benefit. But nowhere in that calculation does the quality of life of future generations really come into it as an explicit kind of parameter or feature.
How obvious is it that it should? I guess, sorry, I'm playing devil's. I don't want to sound like a horrible person, but if all of us here can hope to not like survive, like all the people you care about can't survive past the next 100 years, then how rational is it to care about 100 generations into the future? I'm not saying you shouldn't. I just want to see.
The infinite game is being played at another level that we really can't see or interact with. So there's no point in being virtuous.
I guess the point is, should we care about it? Like, do we care about an infinite game knowing that we are finite creatures? Like you want to play an infinite enough game that you're not like optimizing for the next year and just like destroy the rest of your life. But maybe 100 years should be good enough to plan for. I don't know.
It didn't matter before because we couldn't, humans couldn't affect the infinite outcome. But now suddenly we're in a position where human activity can affect the infinite future. And we're not really set up, we're not really used to that, and we're not prepared for that, and we don't know how to handle it. So
yeah, I mean, that's my point. Like, evolutionarily speaking, like, we are not programmed to care about people that are not even born yet. And I guess I'm questioning, why should you?
I don't have a good answer for you, but well, I don't have a good answer other than I have kids, and I'm hoping that my kids will have kids and they will have kids. And what about them? So if you have kids, which is none of my business, but and you want them to have kids, then these kinds of questions become relevant later in life for many, not just for me. I mean, we have Rob and I in another group where that's the primary concern, which is not for us, but for our children and our children's children. But those features don't really mean anything to somebody who doesn't have kids, because it's an irrelevant point. And I agree that it is an irrelevant point without kids, but some of us have kids, so we have a different view.
But it's some kind of okay, so I understand that you care about the kid, but you also care about your grandchild. I guess that's
the point of having kids is for them to have kids, for them to all that stuff, right?
Okay. Well, that's interesting. That's the
cute, I guess, argue beyond that. Like, does gaining profit really bring satisfaction to life? Like,
that's a very different question.
Right. I mean, maybe this is the wrong forum for that question, but it just feels to me like you're missing the point, right? Like anybody who tries to maximize profit with life, and I think most older people, when they get there, like you don't say at the end of your life, God, I wish I made more money, right? Like we all need a certain level of money to just survive, but
You could, though, if the lack of money caused tragedies in your life,
for
and
sure.
the life of people that you loved.
Yeah, for
And
sure.
so it's like maximizing profit is just shorthand for maximizing some score. Profit is the dollar score. Maybe you're talking about the family satisfaction score, but there's a few scores that the health score, there's few scores that we care about. And we can argue about which one and more and less, but at the end of the day, we're all trying to maximize something.
I actually don't believe that we know what it is we're trying to maximize. For sure, there are elements there that you need, and you might be able to pick those out. But I think it again comes to the unknown unknowns. Like we spend a lot of time, like there's so much effort put into like the science of happiness, which sort of drives me crazy. It's like, seriously, like you honestly think that you're going to go out there and define it? I need this much of this and this much of this and this much of this. Like it's something that's constantly evolving and changing. And whenever you focus on a utility model to get that, I feel like you failed before you even start.
I think it's a great point. This is the Stuart Russell thing, right? So Stuart Russell wrote that book, Human Compatible, where he's talking about how, all the AI that's trying to maximize something, or RL, is not going to work out because, like you just said, everything in life that's important can't be distilled to a single score.
Right.
And so if you automate that process of maximizing some score, just like you'll see with any corporation that purely tries to maximize profit, or an economy that purely tries to maximize one number, the whole thing falls apart, because then you find out that that's not really what you wanted. And so it's important to always maintain some uncertainty about what it is you really want. And that and so he recommends that the AI should keep checking in with us. Is this what you wanted, or am I doing a good job? And we can always say no. So as opposed to telling it maximize that number and then letting it off and go and destroy the world to maximize that number, we just design it such that it's not really sure what it is we want, and its main goal is to do what we want, and we might not even know what we want exactly, which is, I think, of what you were saying.
Yeah, but I think we've sort of touched on this with if we had AI that was really there to maximize our whatever satisfaction with life or whatever it is, but it's tainted from the very beginning because the people who are providing that AI have a different goal than you do. And so, there was that short story that Rob, why am I spacing? Who brought us all together? Robert Ness had us read, where you have this assistant who's helping you, but the assistant is basically just driving you to spend your resources at advertisers, right? And so how do you develop an AI that's really, that's not tainted by that, that's out there to maximize your satisfaction or what's good for humanity? I mean, if we could define what that was, but it's different for everybody.
But I wonder if you could flip it and make the problem easier. Like, let's say we don't know what we want, but we have a pretty clear idea what we don't want. Like, you don't want to be unhealthy, you don't want to be hungry, you don't want to be like, not have any options when you go shopping. So you want to eliminate as many barriers or as many things as you don't like, and then the rest is open for exploration. And I think in that sense, I guess having more money helps you because it alleviates a lot of the simpler problems and lets you explore. So from that sense, I think it's perfectly rational to want to maximize your profit, like subject to some constraints. And I think humans appreciate that already. Like I don't think any human does what Robin was saying, like a robot trying to maximize one thing. Even if you are like the most power hungry or money hungry capitalist, like you still sleep, you take vacation, you care about your children. You're not going to go at all expense and like sell your children's kidneys just to maximize your money, right? That's not usually how it happens.
People come close, actually.
I wouldn't be
No, I'm
surprised. Yeah.
serious. No, I'm serious because people lose sight of it. Like that's the problem, is that when you sort of attach onto one thing and it becomes your source of value, it's very hard to step outside of that again. And you see that all the time with people who are super successful, right? Like at some point in time, you would think you have more money than you could ever possibly spend in your lifetime, right? So the argument that you need that money in order to be able to explore and stuff, right? It's over. So why don't people step away? They can't, right? It's become so ingrained in their values and their identity.
It has to do with has to come, in my opinion anyway, it comes back to the concept of property, right? If you're let's say you're an animal out in the wild and you come across a huge cache of food, your behavior fundamentally changes. You go from this kind of carefree, oh, that looks interesting. Oh no, I don't want to go there. Like you have this kind of free range movement to, oh, I found the pot of gold. I'm going to stay here forever and fight to the death and fend off anybody who comes from my pot of gold. That has nothing to do with conscious choice. That's evolutionarily programmed in, because if you are lucky enough in the wild, very rarely, to come across a huge cache of food that will ensure your survival, the right thing to do is to radically change your behavior from this kind of carefree, exploratory, nomadic mode to this stationary, fight, build walls, buy guns, shoot people, don't, get off my lawn kind of thing. You don't actually have any cognitive control over that. If I gave you $1 million right now, I guarantee your behavior would change. I can't do that.
Let's do that experiment, please.
And then there's some dogs that if they find a giant pile of food, they'll just eat it until they die. Like there's no, yeah, it's just that I don't think that always works. And at the end of the day, we never question that layer of what people want. We always think that's sacred. But actually what we want is so plastic, and it's being influenced all the time by politicians, advertisers, and what they want. And there's this chain of wants that goes up. And it seems like that chain is like kind of taken for granted in RL. And so I've come to a point where I'm like really disillusioned by pretty much everything these days. And I'm hanging out with you guys because I'm like, I wonder if there's anything interesting in machine learning. I'm kind of got really disillusioned by it. And so I'm trying to figure out what the next thing is. But it seems to me it has to do with this. What is it that you want thing and the plasticity of that? Because it seems like with the way everything is, we all want the wrong things. And so the ship's not going in a great direction. But there's not a lot of talk about improving what it is we want. Improving the nature of our wants. Like seems like outside of the realm of discussion in general.
Sounds like philosophy, I guess, ancient philosophy.
Robin, have you read The Master and His Emissary, that book that we've discussed?
What's it called again?
The Master and His Emissary.
I apparently haven't, because I asked the title twice. Master, no. Is it about that?
I think it's about that. I don't know.
I think it's about that. Yeah.
Read it.
Okay.
I mean, it's a commitment. It's a commitment, but yeah, I think you should read it.
So my response to you, Robin, is I agree. And my approach is to do the following, and I'll just put it out there, which is to go back to that categorical picture I was showing earlier, where there's any number of ways that we could explain observed phenomena. Can we use cognitive agents to do speculative intervention in the virtual, or potentially even in the physical? Could we build machines that try to be scientists and explore different things, and then use them as beacons? Wow, you were able to get there. How did you get there? And it kind of leaves a breadcrumb trail as to how it arrived at that wonderful place. So if we have a multi-agent simulation where we take a little town and we allow the agents in the town to change the town over time, or we use a genetic algorithm to build lots of different towns, and we find a town where everyone's pretty happy and they're having a good time and nobody's dying of horrible diseases and they're not destroying the environment. We can use those simulations as beacons that we can move towards as a culture. Right. So rather than waiting for science fiction authors to kind of gaze into the crystal ball and come up with possible futures, can we semi-automate that process and look for optimality nearby in lots of places using our machines, and then
But why do you
as
think that
humans-
simulator? Yeah.
Hmm?
Why do you think that tells us anything about the real world? Something in a
it
simplified
doesn't-
simulation.
no, it tells
it's
us where
so
we
far.
could be.
But like we played SimCity, right? But there's not. It's hard to get any lessons of that from the real world, because the real world is the difference in complexity is like so many orders of magnitude that it's hard to distill any lessons from one to the other. Like it's not really.
I'm just
It's such a
suggesting
toy.
that we need new ideals, and they are ideal. They're not plausible, but if there are new destinations, new configurations that we perceive to be better than where we are, I think that we might move towards them. No?
Yeah, I'm really skeptical. Like there's like this whole AI economist stuff where they're using AI and RL to like design tax codes and all this stuff. And this is from Salesforce. And people go really far into these virtual worlds. And like, I'm always just at the end of it, I'm like, okay, how can you say that that tells you anything in any way about the real world? It's so far from reality that, I mean, you could like, yeah, it just seems like there's no way to link it to the real world. So yeah, that I guess it did interest me for a while, but now it seems a little bit.
I would disagree, Robin. I think there's actually, I'm kind of on David's camp here. I mean, I think there's a lot of things that can be potentially solved in that type of framework that are highly useful. I mean, you brought up taxes, okay. You know, there's no analytical way of really figuring out what a good tax strategy is for a government or for an individual trying to optimize around constraints. So you're almost in, I mean, it's kind of like a bin packing problem. It's not one that leads itself to an analytical solution, and that puts it right back in kind of an RL framework.
But the realism of your simulator becomes everything, right? RL is expert at gaming bad simulators. And so that's all you're going to do. You're going to find many ways to game your bad simulators, and you're going to spend your whole career doing that. And that doesn't seem like it's going to have much effect on the real world.
You know, I guess it kind of hinges on how much you're really asking of it. You know, if you're trying to design policy and you run it through a simulator and you conclude that people could do this and game it, you know, I view that as useful.
I'll give you a brief demonstration of something I've been working on right now, just for fun. Let me set it up here. It'll take a couple of minutes to carry on.
While you're setting that up, I think it relates to a concept Stephen Wolfram always talks about. He calls it irreducible complexity. So he argues some systems are so complex that in order to simulate it, you need the system. Like you can't have a program that's simpler that simulates a super complex system. Whether or not a system is like that, that's, I guess, something that we don't know. But there are, so you could argue human beings are such a system. And if you want to actually sort of simulate the human beings in a way that is useful for predicting an explanation, you need to almost make a human beings and make them run. It's impossible to code something that will simulate what a human being does.
So maybe we could, maybe in that sense, we could do experiments. We could say, let's change the tax code in one city and see what has happened. And then you're actually doing that, right?
Expensive, right? Yeah, those are expensive. But how about something like Westworld? Like, have you guys seen the series? Like, imagine having humans go into artificial situations and see how they behave, and then use that to predict how similar humans in the similar situation will behave in the future.
So there is something like that.
Yeah.
Like, so I've been hanging out in crypto for the past few months. Like I completely left AI and hung out in crypto. And crypto is a very weird, strange world. The incentive is very simple, is to maximize the profit. And there's many experiments all the time. It's like a little mini economy that's divorced from a lot of the things in the real world. And people are making the strangest innovations and incentives in that world. And so it's actually like running all these experiments, economic experiments. It's a crazy world. I wouldn't recommend anyone go there. But there's so many economic experiments going on in there, and because they're real actors that really have coins, they're real economic entities that are working it, that are hanging out in there, And so you can actually get some insight. So to me, I think the whole idea of like mechanism design and game theory, maybe it seems like to me where maybe part of the puzzle is and part of the answers are. Yeah.
Okay, you go ahead. Yeah, no, I agree.
Oh, I just kick in one note about the crypto world. I've had a number of conversations with people recently, and they say that all the smart people now are drifting into crypto. So maybe they used to be running a hedge fund or something. Now it's all in crypto. Maybe they used to be in science.
Well, there's also a lot of dumb people there.
Well, that's why the smart people are going, to feed off the dumb people.
It's like 99.9% scammers, and then the rest are mostly idiots. And then there may be a few. I have found a few. I'm not saying I'm smart. I found a few smart people there. I'm just trying to figure out what's going on. Like, it's a very strange, complicated world in there. But the fact is, it seems to me like the economy is really the real world economy is a really messed up, complicated thing. We don't really understand it. It's not doing the right thing. It's super broken. I wish we could run a ton of experiments to understand economics. We can't. It's really hard to do in the real world, but that is actually happening in there to some degree. So
I'll just give you a brief demo of what I've been working on for the last little while and try and give you an explanation. So I'll just kind of drop you in. Excuse me, I'm just going to drop into VR. I'll share my screen with you. Oh, hang on. It's not there. One sec.
is that a VR headset you have?
It is. I used to make them.
You used to make these headsets?
Yes.
No way.
Yes, sir.
I did not know that.
Yes. Okay. All right. So this is, oh, sorry. So I'm in this virtual environment here. I'm working with a bunch of guys out of Simon Fraser on this project. And the idea is that you can freely fly around this world without getting sick, right? So I can basically, and there's a teleport mechanism that allows me to move very quickly. So I can essentially fly up into the sky very quickly, and then, oops, sorry. Oh, I think I've lost track here. One second.
It looks like BC.
But I'll stop that for a moment because that's not my point. So the idea is that I want to build a generative model that is non-Euclidean. Okay, so the idea is that you as a human being can fly around parameter space and find parameter spaces that resonate with what you want, if that makes sense. So I'm flying through the world and I see a forest, I see a city, and I see a lake, all right? And if I go to the lake, then I like the lake, but this lake isn't very nice. I want a different kind of lake. So if I fly up into the sky, I'll see this lake and I'll see some variety of lakes around me. And I can essentially fly to the lake that I like that time, and I can continue to refine my, essentially, I can use my system one to navigate in this kind of generative environment. And the hope is that this might reveal some insight about what it is that we want, where we want to be, where we want to go. Okay, like what, you know, if you could be rich and live in a great big house, well, there's a great big house, you can go and live in it. Oh, this isn't what I wanted. Maybe I didn't want a big house. Maybe I wanted a house by a lake. Let me go to a house by a lake and try that. Oh, I really like this. This is what I want.
These are procedurally generated, or
Yes.
or you generated by like saying, okay, I want a bigger table, and then it generates a bigger table, or what?
No, you literally just move around, right? It's generating nearby, they're not counterfactual, they are interventions. So it's taking interventions. It's changing the parameters space that you're in some small way. And then you can move to parts of the parameter space just by flying without getting sick to help you essentially find what you're looking for, if that makes sense. So there's a variety of different ideas. One idea is I'm an architect and I've designed this building and I'm going to put it there. And then I'm standing outside the building and I'm flying around and I like it. And then there are variations of the building nearby. So I can fly over here and here's the 4-story version or the 2-story version or the more glass version or the less glass version. So to go back to Robin's point about humans being in the loop from the, what was the name of the book again, Robin?
Human Compatible by
Human
Stuart
Compatible,
Russell.
right. So in a sense, I think that's what Human Compatible is trying to get to, which is we have this AI that can use data from the real world to generate these possible futures, but it doesn't know which one we care about. Can we just fly to the one that we want? Anyway, so that's what I'm kind of exploring. I'm curious as to what pitfalls I'm likely to fall into.
It looks really cool.
Yeah, we're hoping to show this at SIGGRAPH in Vancouver this year. So we're putting in to do the floor demo for that. But I mean, there's a ton of other people involved who've done all the hard work. I just kind of glued it together. But the idea is to try and couple low-level cognitive systems like system 1, as it were, to these models and see where that takes us, right? Because I don't think that the language models that we've come up with are doing a good job, right? So who was it that said that language was invented to be able to lie to people? I can't remember who said that, but it was someone very famous long ago. Can we try and get past the language and into something a little bit more human, as it were, or biological? I don't know. But,
so do you think such simulations help you discover what you like or help you construct what you like by interacting with it?
It helps you know what you like, if you will. It gives a voice to system 1. I don't know what I want. What do I want? Do you want this or that? I have no idea. Okay,
yeah, but I would say, like, depending on what you show in what order and the way you interact, you are going to end up in different places that you like.
Which is why it's non-Euclidean. The point isn't to take you somewhere finite, is to essentially give you a sense that you have choice for a beginning, right? There are alternatives, okay? That alone, I think, would be novel to many people because they think they're stuck on a train and there's no doors and they can't get off, right? And if you can give people a sense that they can, without having $1 million, go and live in the house by the lake for an afternoon just to see what that's like, that might prevent them having to spend the next 20 years paying off a mortgage and then moving to the house and saying, oh, this sucks, I hated that. What was all that about, right? So you can kind of taste, if you will.
Very Ready Player One.
Yeah.
Do you think you can experience living in a house through a simulation?
Yes.
And what if you like it? then you just keep getting yourself plugged in. If you don't like it, that's great. You realize you don't need all that money anyways. But let's say you really liked it. Is this the solution, to just keep going into the simulation to enjoy it? Because you can't afford it. It's not like you can create what you want.
But you can afford it virtually.
Yeah, but is that a good thing? I don't know.
I feel like this is...
It's like real estate pornography.
Well, I guess we're going to go with it. It's like online dating, resume screening, all of that, right? You have these representations of things in the real world, and you're trying to simplify something that's out there and allow people to grasp it in a smaller way.
I'm
actually experiencing it.
Yeah. So to go into the kind of the theory very briefly, this gets into Kantian philosophy, Kantian categories. So he has this concept, I've talked about it before, the idea of totality versus plurality versus unity, right? So system 2 and grasping are all about, so you can think of system 2 as being plurality and grasping as being unity. And what I'm trying to do is I'm trying to actually bypass those and actually get into just you having a visceral experience, right, without language, and trying to make an assessment without saying, somebody tapping on the shoulder saying, eat at Joe's, right? So to give you a sense that you can turn off all that kind of buzz from the internet, if you will, and just be in a place that you want to be without language, without having to worry about anything. You're just flying around, you're just walking down the street, whatever it might be. I think that that's what we're missing, right? We're so plugged into all our digital gadgets, he says, putting a digital gadget on his face, that we're so living in a world of language that we've forgotten how to kind of connect with that aspect of ourselves, I guess. So that's what I'm exploring.
Yeah, I like the ideas. It's the point at which we try and create the representation of it. It's just that's where it gets difficult, right? At the end of the day, we're biological creatures.
Yeah. And
it feels like that's where a lot of the problems are coming from. We're sort of trying to.
I think the problems are coming from language, not biology. But
no, I agree with you. I don't even know it's necessarily language, but with not
the human
seeing,
condition, whatever you want to call it.
Yeah, not seeing reality for what it is and trying to grasp onto some model of it and thinking that that's gonna give you answers.
So to return right back to the beginning of the paper, I guess where I'm coming down on the side of is I'm trying to bypass explanation. I am trying to allow you to predict without explanation. What do you like, right? You don't have to tell me in words, just fly to where you want. Because I think the explanations are good at first, but then they become entrenched and parasitized and become, you know, this kind of valley that you can't escape from. Mm-hmm. And perhaps prediction is better than explanation in a sense, because explanations only work in language. They don't work in, you know, our non-linguistic subsystems. So I don't know, but
we should read some Wittgenstein next if
yes.
you really hate language.
I was actually coming today to that was one of the things that I would love to do. I feel like some of those philosophical papers that we read, like I found that really useful. I would love to read some Wittgenstein next.
Okay.
At some level, it could all be language, right? Like some people say, everything we do when we dance, that's like a linguistic thing. We're making an egg, that's kind of a linguistic process. It's the language of our movements, or the language of like everything. Maybe I believe that everything boils down to language at some level.
But that means that you're a modeler, right? You think that we can represent everything as models.
Well, we have to try to do that as humans.
That's
the only way we can make sense of anything is to somehow make it.
Can your dog make sense of anything?
I think they would have their level of language, whatever they have to work with.
I'm not disputing it. I'm just
an idea.
It's you're stretching the definition of language, like the same way like people do it with computation. Like everything is computation. The universe is computing. Like at some point it becomes useless, because if everything is one thing, then you don't really need to come up with that word to explain that one thing. But I feel like language, I think David is talking about like literal language, like words and speech. If you want to define it to capture more things, like any sort of communication, I guess that's what you're saying, then that's a separate thing, I would say. Then you can even take it another level, right? Just call it all information, right? It's all about information. What information are you conveying when you're dancing to the next person? And it's all about information processing. It's all about computation. Then it becomes, again, not very useful.
So what should we go to next week? We're over time here, folks. Sorry about that. But would you like to try some Wittgenstein? I haven't read his first book. Apparently it's very difficult. Philosophical Investigations is easier. That's the one I've read.
I tried Tractatus, but that was like the strangest book.
That's brutal. No, that's the one.
Like, I had no idea. Yeah. I think he said about the book that if you only people who have already thought about what's in the book would understand what the book is saying. Otherwise, you would not get anything out of it. So right. I guess I haven't thought about it.
So, but he has another book. Transform RL models. Action can be modeled in language. Okay, sorry. So do we want to have a shot at Wittgenstein's Philosophical Investigations. It's a book later in his life. It's a little bit more accessible.
Do you want to read the whole book in a week? I guess you can.
No,
I don't
no,
have
no.
the time.
What about if we go back to the Stanford?
Yeah, exactly. Why don't we
and
go
get
the
the sort of-
Stanford road? Yeah.
Yeah, get the overview first of all, and then see if we like it enough that we want to commit to the book.
Okay. I'll do the research and plug that into the reading group. Sounds great.
I also share this thing with you guys. I'm not saying we should cover it here, but it was really good. It's this lecture on like causal modeling by McElrath. It's a causal inference workshop. He comes up with really simple like explanations and things of why we need causal models. If you need more of that, like, and he goes through actual detailed examples. It's a 3-hour workshop, but I found it really well explained.
Big graph because you can break it apart.
I also found the conversation between Wolfram and Taleb surprisingly insightful. I mean, Taleb's an obnoxious toad at the best of times, but he was actually on his best behavior, and it's very interesting. So if you have some time and you're interested in his view, I actually found it quite good. It's very interesting. He had a lot to say about economics. It wasn't very nice, but
He's very
He
funny.
really likes it. Yeah, he likes those fat tails. He's been writing books about them for decades now.
yeah. But then it was actually a very good interview, and there's actually some pretty interesting stuff in it. Just type in Wolfram and Taleb, and it'll pop up, I'm sure. Okay, folks, great. All right, so next time
Sounds
it'll
good.
be Wittgenstein on Stanford's Plato. I hope you can join us, Robin. We'd love to have your input. Okay, take care, everyone.
Bye.
Okay.
Bye.